Hello and welcome back to Data Analysis and Visualization. I'm Jivita Christie, and in this video, I'm going to explain to you comparative graphics and statistical plots. So we are going to explore from, in the previous video, we saw some standard charts which can be used for data visualization, and you got a lot to choose from. And now we are going to add some more options to that by checking comparative graphics as well as statistical plots. So let's begin. First, we are going to explore comparative graphics. A comparative graphic is a graphic that displays the relative value of multiple parameters in a shared category or the relatedness of parameters within multiple shared categories. The core difference between comparative graphics and standard graphics is that comparative graphics offer you a way to simultaneously compare more than one parameter and category. So if that is your goal, to compare more than one parameter or category, then you would be using comparative graphics. So comparative graphics are much different than standard graphics because they allow you to compare multiple categories and parameters. So let's take a look. Standard graphics provide you a way to view and compare only the difference between one parameter of any single category. Comparative graphics are geared for an audience that's at least slightly analytical, so you can easily use these graphics in either data storytelling or data showcasing. So standard graphics allow you to compare and find difference between one parameter, single category. Comparative graphics can compare multiple parameters, multiple categories, and that's why you would use it only for an audience that's slightly analytical. So not for data art, obviously, but you would use it for storytelling or showcasing. Visually speaking, comparative graphics are more complex than standard graphics. And let's see a few different types of popular comparative graphics. So first we have bubble plots. Bubble plots use bubble size and color to demonstrate the relationship between three parameters of the same category. So when you have three parameters to compare belonging to the same category, then you would use a bubble plot. And in a bubble plot, you have bubble size, which is one way to control and compare, and as well as the color of the bubble that could help you to control and compare. And let's take a look at an example. So this right here is an example, which is about risk assessment for Q1 opportunities. And here you can see how the size of the bubble as well as the color of the bubble depicts something. If you see here, right here, you'll be able to notice that there are some things mentioned over here. So each color has a different meaning over here. So you can see there is sales, product, marketing, blue. Blue is marketing, and light blue is sales, and pink is product. And up there, the size also depicts the chance of success. So if the size is smaller, then there is this much percentage of chance of success. If it's bigger, this much, even bigger than this much. So you can see how the size as well as the color helps you to make better comparisons using bubble plots. Next, we have packed circle diagrams. Packed circle diagrams use both circle size and clustering to visualize the relationships between categories, parameters, and relative parameter values. So here, you don't just use the size, but you also use clustering. And this is what it looks like. This is an example of a packed circle diagram. You can see how the colors are different, as well as the size is different, and you can also notice how they are clustered together. So based on the cluster, you can also perform comparisons. And you can pause here, zoom in, and take a little bit closer look at what this is showing. Next, we have Gantt charts. And if you have studied something like operating systems and you've seen process scheduling or any type of scheduling, then you might be very familiar with Gantt charts. A Gantt chart is nothing but a bar chart that uses horizontal bars to visualize scheduling requirements for project management purposes. This type of chart is useful when you're developing a plan for project delivery. It's also helpful when working to determine the sequence in which tasks must be completed in order to meet delivery timelines. And they are great for project management and scheduling. So they allow you to schedule things in sequence. So they allow you to put things in a sequence. And at the same time, they allow you to sort of set a deadline for each of those tasks. Let's take a look at a Gantt chart. This is a Gantt chart, very easy to understand. You can see there are tasks mentioned on the left side, planning, research, design, implementation, follow-up. So it's a project. And there are 3 quarters mentioned of 2019, Q1, Q2, Q3. The months are mentioned, Jan, Feb, March, April, June, and July. And you can see wherever you see the blue area, that means that you're starting your planning phase in Jan and finishing it by March. So that way you can know what is to be done first. You can know that planning has to be done first, then research will start somewhere while planning is going on. Design will start while research and planning both are going on. And then simultaneously you'll be starting implementation also, but that's after planning and research are over and design is going on. So it's a very, very simple look, and it allows you to understand how to do scheduling as well as sequencing. Next, we have stacked charts. Stacked charts are used to compare multiple attributes of parameters in the same category. To ensure that it doesn't become difficult to make a visual comparison, don't include too many parameters. So you can compare many parameters belonging to the same category, but if you don't want your visualization to become very complicated and difficult to understand, you would want to limit the number of parameters. And stacked charts look like this. So they are almost like histograms and bar charts. They look the same, but there are different parameters. You can see a little bit of color that's appearing, and that color has a significance. You can read that right here. What different colors mean, that's given right here. So you can have multiple parameters added to your bar charts or histograms by using stacked charts. You can, of course, pause and take a closer look at it so you can understand it better. Then we have tree maps. Tree maps aggregate parameters of like categories and then use area to show the relative size of each category compared to the whole. So this is all about aggregation, combining parameters belonging to the same category, and then use area to show the relative size of each category when you're comparing it as a whole with another one. And it looks something like this. You can see there are areas divided. There's Asia, there's Africa, Europe, North America, South America. Of course, all these colors that you see are also meaning something. So for example, maybe you're trying to say how much water is there in each of these continents, and maybe you want to show it with a blue color, then that's what the blue here means, that this is the area that is water. Of course, that might mean Europe is completely underwater. I'm not trying to say that, but I'm just giving an example that blue could mean this. You could also associate it with trade or commerce related things, what kind of things Asia is able to sell. And based on that, maybe you could create this type of a graph. So this is a tree map, which can be used in this manner, where you're grouping things together and you're combining parameters and comparing parameters of one area with another. Next, we have word clouds. Word clouds use size and color to show the relative difference in frequency of words used in a body of text. So this is completely based on words. If you have a piece of text with a lot of words in it, you can create a word cloud and use different sizes. If some word is appearing very frequently in your text, then you would make it bigger in size in your word cloud, as well as show some different type of a color to it that you want. And colors are generally employed to indicate classifications of words by usage type. So maybe there are some technical words and you want to classify those, then maybe you want to color them differently, maybe color them red or something. So that would be a word cloud. Here is an example of a word cloud, which is completely black and white. But you can see that words like every and nation and new and America, they stand out. The reason for that being that the text that we used to create this word cloud had nation, America, and new appearing more frequently than the rest of the words. So this is a word cloud right here. Now let's explore statistical plots. So these were all comparative graphics. Now we're going to see statistical plots for data visualization. Statistical plots, which show the results of statistical analysis, are usually useful only to a deeply analytical audience. So not useful for making data art, as well as not very useful for creating even data storytelling, because if you have a very analytical audience, then you would be choosing data showcasing. So that is where statistical plots are useful. One such plot is a histogram. Diagrams that plot a variable's frequency and distribution as rectangles on a chart. Histograms can help you to get a quick handle of on the distribution and frequency of your data in your dataset. And get comfortable with histograms. You're going to see a lot of them in the course of statistical analysis. So if you're performing any type of statistical analysis, you have to get comfortable with histograms. They are used a lot. And I've already shown you a couple in couple of videos when I began this series on data analysis and visualization. We saw lots of histograms. We saw what frequency distributions are. We saw what probability distributions are using histograms. So they are very helpful for any type of statistical analysis. But of course, if you are showing it to an audience that is not analytical minded, then for them, this is a simple bar chart. But to an audience that is analytical, who knows statistics, they'll be able to understand that, you know, there is some distribution going on here. How much skewness is there? How much symmetry is there? They would try to find out what outliers are there, you know, which distribution is it? Is it normal distribution? Is it geometric? All those things will be interpreted by such an audience. So this is a simple histogram, and of course, it's not very difficult to understand what's happening here. There's an X and Y axis, and you can see those rectangles that are either higher or lower depending on values of Y corresponding to the values of X. Next are scatter plots. A terrific way to quickly uncover significant trends and outliers in your dataset. Scatter plots plot data points according to their X and Y values in order to visually reveal any significant patterns. So you might be familiar with scatter plots already if you have watched videos which I created on linear regression, multivariate regression, as well as polynomial regression. We saw a bunch of scatter plots there. So it's simply plotting your X and Y positions, and it may not mean much to a non-analytical audience, but to an analytical audience, it would mean a lot because they would be able to find out trends. They would be able to identify outliers using these plots. If you use data storytelling or data showcasing, start off by generating a quick scatter plot to get a basic idea for areas in the dataset that you could likely find interesting, areas that could potentially uncover significant relationships or yield persuasive stories. So creating a scatter plot is not just for your audience, it could be just for you when you are picking up a data analytics project and you want to understand if the data has some interesting trends or outliers or some patterns, and you want to see that, then you would create a scatter plot just to understand what kind of trends could be found out from this type of data. And I cannot even begin to explain to you how important scatter plots are for regressions. When we did that, we saw scatter plots and we saw the regression line and we were able to tell whether the line is actually helpful in our type of data or not. So here is an example of a scatter plot. You can see those tiny dots. They are just X and Y positions marked based on the data points that we have in our data set. So you can once again take a closer look, zoom in, pause, and take a closer look if you would like. Now, just like scatter plots, there are also scatter plot matrices. Okay. And a good choice when you want to explore the relationships between several variables, scatterplot matrices place their scatter plots in a visual series that shows correlations between multiple variables. So these are not just simple scatter plots. There are scatter plots, but they are shown in different types of plots. They are shown in different matrices. So there's one matrix with scatter plots, there's a second matrix with scatter plots, and then a third one, and so on. So how that helps is when you see so many matrices of scatter plots together, then you can see correlation between multiple variables. Discovering and verifying relationships between variables can help you to identify clusters among your variables and to identify oddball outliers in your data set. So creating scatterplot matrices helps you to identify outliers as well as clusters in your data set. Data which is very similar and data which is not similar at all, it's somewhere far away. Here you can see an example of scatterplot matrices. This is what they look like. You can see there are different boxes, and within those boxes there are scatterplots. So that's it for comparative and statistical types of graphic charts. In the next video, we are going to see a few more of these types. And so I'll be back with the next video and I'll see you there. And thank you for